Hey everyone, my name is Johan. I'm here to talk a bit about not forking around or how we are leveraging NRI to extend the Kubernetes scales. And as mentioned, Wes will be joining me later on the stage. So you might have heard about us, we're Uber. This morning I took an Uber out here. How many else took an Uber out here this morning? Okay, a couple of handfuls. If you take about like the Danish populations multiplied by 6, every single person in Denmark took 6 rides every single day. That's about the number of trips that we're doing every single day. So that's like 1.5 million trips per hour. Out here, behind all these scenes, driving all of these deliveries and trips that we have, we're also running a bunch of containers. And that's the more interesting aspects I'm going to talk about today. So we have 8.3 million containers, and these are running across many different container platforms. The container platform that Wes and I are working on is the Stateful platform. It's a platform that's evolved over many years, and it's driving like 3 million of these containers across 100,000 of hosts. We're running more than 400,000 workloads, so that's like database nodes on the platform. We do have multiple container platforms at Uber. The Stateful one is, of course, for databases. Anything that kind of needs state, storage systems, anything that relies on having access to disks or persisting state. We're also running a stateless container platform. That's for all the microservices, and it's for APIs, serverless stuff, and anything that doesn't really need states. And then, of course, we have a batch platform that does all the data processing, analytics, figuring out all sorts of optimal pricing calculations and anything else. For the latter two, our stateless and our batch platforms, they've already been migrated over towards Kubernetes. And we've been talking about this at previous conferences as well, how we've done migration from Mesos and moving towards Kubernetes and running all our containers over there. But the holdout at the moment is our Stateful platform. It's a proprietary platform that we've been developing over the past 8 years. It has evolved in kind of like orthogonal into where Kubernetes are, and it's a platform that's developed a lot of specific features. But having the two other platforms already running on Kubernetes, we also see a lot of benefits. And I doubt I have to convince any of you why it might be smart to moving towards Kubernetes. We get a lot of a common layer, common tooling, things we don't have to implement multiple different times, but rather things we can reuse components, how we're thinking about things, observability. It just gives us a lot of benefits to be on the same platform. Unfortunately, we do have one drawback, and that is our platform has evolved with a lot of specific features that we need. And Kubernetes are lacking a lot of these features. So that's the main problem is how do we kind of align towards these features that are and the difference in features between Kubernetes and our platform. Okay, the bane of kind of any developer is business requirements. This platform that we've been building, it doesn't really, it has very specific needs on our for our stakeholders, for our platform, a lot of features that the business has evolved to kind of depend on over the years. As I mentioned, our platform is more than 8 years old. That means that we have evolved a lot of the features that we now see today in Kubernetes. Those features we have also similarly developed and implemented over many years. And that becomes a business requirement that we have from our stakeholders, the database teams that are running all of the fleet of databases, and all of the product teams that are now kind of depending on those features and optimizations that we built on our old platform. Now we want to do the migration to Kubernetes, and that gives us a lot of challenges. So what kind of features is it that we're actually talking about? What has kind of shaped our platform over all of these many years? Well, Uber has been running on our own data centers. So by having our own data centers, we've also have a lot of hosts running with our own hard disk and SSDs. Having locally attached disks, that means that we now have a dependency on local disks. We're not using remote block storage. And the downside when you're having stateful workloads and you have local disks is that it makes it really difficult to try to move your workload from one specific host into another host. If you see like any kind of like optimizations, performance, things we can do to either like closer pack all of our workloads together on specific hosts to save us money, then those operations becomes quite difficult. We can't just like delete a pod, recreate it somewhere else, and have it immediately pop up. We need to be able to sync the data from one specific host over to another host. That has, of course, meant that we are now building a lot of features on our platform to help us do in-place adjustments of these resources. We want to be able to mutate any of our requirements in place so we don't have to do expensive operations by moving the workloads instead. So, what kind of features are we talking about here? We kind of like group them into two buckets of features. One of them is how we do resource controls. So resource controls, that's how we do CPU and memory. CPU we can do by using CPU sets, and both CPU and memory are fully controlled through C groups. We also have a feature that allows us to over-allocate our specific workloads on the hosts. So basically, all the pods running on a given node, they can now allocate in a burst into a shared pool of resources that helps us a lot with how we do performance optimizations and like how we basically get better CPU usage on these hosts because they're allowed to spike in to a pool that's not otherwise being used. We also have a thing called pod level resources. And the pod level resources are essentially allowing us to do the bursting, but within a given pod. So for the specific containers, we can put in constraints for some sidecar containers, and then allow the main database containers to use any other resources available within that specific pod. But we don't need to specify all of the resource requirements for every single container. We also have container controls, as we call it here, basically allowing us to do adding and removing containers on the fly. We don't have to be able to recreate any kind of pods, but we can dynamically add the new containers, adjusting container labels, which we do for like low-level logging stack and integrations into the Uber platform at large. And then we have container runtime policies as well. How are we able to adjust out-of-memory scores? How do we do CPU scheduler priorities? Essentially specifying for a given workload, how do we down-prioritize sidecar containers, get them to OM first before our actually database containers that they are before they out of memory. Okay, so we kind of have this gap between where we are today, where Kubernetes is today, and the upstream on Kubernetes. So the ideal, that would be Kubernetes already has all the features that we need, right? So that's a kind of, you're looking at an open source project and you're like, yes, finally, it hits all the things that you actually need and you can just start using it. Unfortunately, that's not the reality. Instead, we're seeing that a lot of these features are not quite there yet. Some of them are slowly coming in, getting implemented, but they're not there at the moment, and it might take a while before we actually see them in native Kubernetes and upstream Kubernetes. In the meantime, we of course, as any other developer, have some pressure from the business side. We want to deliver some benefits to the business. We want to be able to argue why is the things that we're doing beneficial to the company. And if you can only deliver some things way out in the future, well, we'd really like to get more of the benefits that we were talking about before on how can we actually get the common layer of Kubernetes and use that across the whole company. So when you're in a big company, you sometimes get a bit of tempted. You kind of want to see like, well, if Kubernetes doesn't have it at the moment, can we fork Kubernetes? Can we implement it? Can we get everything done? It is kind of like a big company problem sometimes, but it does give us like full control. It does give us the immediate results and that we can implement it. We can do all the things we need to do inside of Kubernetes. We've already built on once in our platform, and we kind of want to upstream these features. So if you just do all of these things now and immediately, we can get like a specific Uber-tailored solution Unfortunately, there are some downsides to this approach as well. Having a fork of Kubernetes means that we now have to maintain a fork, but we don't want to be on an old version of Kubernetes. We want to be able to upgrade to the Kubernetes, the newer version of Kubernetes that provides the new features that we actually need. We're also a bit more isolated from the community. We're just doing our own things on Kubernetes, whereas we actually want to be able to leverage more of the Kubernetes community and these conferences. We're also accruing a lot of long-term technical debt and having to maintain our own fork. And especially the latter two, given that we already have been running on a proprietary platform, we already see that we are isolated from the community because we're actually not even part of the community on that platform. And we also have a lot of long-term technical debt that we've been accruing over many years. So it doesn't really give us a lot of benefits. We're just getting some of the Kubernetes stuff, but we don't really make the move forward that we actually want to do. Okay, so why don't we actually just upstream all of these things? Well, getting things upstream is not always that easy. We actually want to get a bit more community consensus, see what kind of features make sense for the Kubernetes community at large. How can we might be able to change the specs more to fitting into future changes and future pod mutability and other specs that are coming into newer version of Kubernetes. But we still got a bit of production urgency. So what might we do as the next step? I'll bring up Wesley to talk a bit more about how we're solving this problem.
Thank you, Johan. My name is Wesley. I've also been working together with Johan on the on Uber's stateful container platform. And so I'd like to talk about the way forward. So Johan mentioned all these problems that we have and how we might solve them by forking Kubernetes, but that poses the question, how can we support all of these features that we mentioned on our stateful platform without actually forking Kubernetes? So the solution for this and the way forward is the Node Resource Interface, or NRI for short. Up here on the screen, I took it from the Containerd's NRI repo. This is the first sentence. I think it's a nice short and sweet explanation of what NRI actually does. But in essence, what NRI is it gives us the ability to change containers before they start. So you can imagine maybe how we could use that, and it's also quite a powerful tool that we can leverage. However, I'm a bit more of a visual person, so let's take a look at how this actually looks with some boxes and arrows pointing around. To do that, we have to know how do we actually create a container? So what is needed for a container itself? The first thing we need is a container runtime. So this is runc, kata, there's other ones as well. These are running on the host itself. This is also the low-level component that does all the heavy lifting. This is the component that's going to create the container at the end of the day. It'll talk to the Linux kernel, do syscalls, all that fun stuff. To actually create a container, the container runtime needs to get some information, like how does it know how to create this container. So as input, we provide an OCI bundle. So this bundle contains resource settings, mounts, args, a whole bunch of other stuff. It's the recipe for the container, if you will. So where does NRI come in? Node Resource Interface. What NRI enables us to do is it allows us to change this OCI bundle before it makes its way to the container runtime. This is how we insert our custom logic per se, because we can have some logic running and then change the bundle before it makes its way to the runtime before the container started. So there we can tweak C group settings, we can add extra mounts, we can inject device configuration, we can do essentially whatever we want to the container. However, I haven't mentioned how Kubernetes plays a role yet in this picture. So to do that, let's take a step back. Let's look at all the components that are involved in this. So up here, I have the entire flow and where NRI will be involved, but let's just start at the front. So we have a pod. We're at Cloud Native Denmark. We all know what a pod is. It contains a list of containers. It contains a list of containers and some other configuration for these containers. And then we have the kubelet. So the kubelet's running on all of the Kubernetes nodes. It watches the pods, sees, okay, we have a pod, now we need to create a container. What the kubelet does is it calls out to the CRI runtime. So this is containerd, cryo, there's other ones as well. It translates that request. It also maintains some state and reports back to kubelet. And the container runtime will then process the request that it received from kubelet, and it processes, or it forwards it to the container runtime, so it can actually create the container. If you remembered at the beginning, I showed you this quote where from containerd. We also have containerd here as the CRI runtime. So if you can imagine, NRI will also be living inside of the CRI runtime. So let's take a closer look at that. I've zoomed in here, and on the left, we get the information from kubelet. We have the CRI runtime. And then the node resource interface lives inside of here, so it's an interface, and it provides the infrastructure as well. So we can register something called a plugin. So we can register it on the NRI socket, and then whenever the request comes in, CRI starts processing it, and then NRI will also send the request to the NRI plugin, at which point we can do our custom logic, make changes to the request. We're also running on the host as well, so we can make direct changes on the host if need be. Then we return the response, and the CRI runtime just continues as normal, sends the OCI request, goes to the runtime, we create the container. So we have the mechanism, we have a tool, the NRI. It's a very powerful and incredible tool, but somehow we also have to configure the NRI. We have to declare what the NRI plugin should be doing. So what should it be doing for a given pod or a container, and how did we go about this? As you can probably imagine, so the entire point of this talk is not to fork Kubernetes and to, reduce tech debt. And we're moving to Kubernetes, so we also wanted to stay Kubernetes native as possible. So what we did is we turned the NRI plugin, we turned it into a controller. So the NRI plugin was running as a normal Kubernetes controller. And we also created a custom resource, which we called a pod extension. This pod extension is, as you can imagine, it extends the pods with specs that we need to add all of these stateful features that we needed. So in essence, these are things that we would like to actually see inside of the pod spec, but weren't there. So this was our way of forking Kubernetes without forking it by just extending it this way in a very Kubernetes native way, while also having the NRI plugin do more advanced stuff on the low level. This pod extension, we can configure it in multiple ways. So some of the features that we can add, I'd like to mention that so at Uber for our stateful platform, we're using CPU sets instead of CPU quotas, which was something that gave us a lot of efficiency gains that colleagues have been working on over the years. If you don't know what CPU sets or CPU quotas are, don't worry about it. It's just, what I want to say with this is we're not using any of the resources on the pod itself. We're managing all of the resources ourselves using the pod extension. So we're interacting with the C groups directly, and we do all of this via the pod extension. Some other things we can configure is, like Johan mentioned, we can configure things on the pod level. So we can say, for this entire pod, this pod only has access to 10 CPUs, for example. Then containers inside of the pod, we can also configure them. So then we can bound, so up here on the screen I have a container foo. It is bound to 4 CPUs. It cannot exceed that. And then the last container bar, it can burst into everything that's available in the entire pod. This is not normally something that's possible in vanilla Kubernetes, but we extended it this way. Also, these pod level resources, at the time when we built this wasn't a feature yet in upstream Kubernetes, but if you're aware, this is also like a relatively new feature that's coming out, even 1.34 beta. Yeah. With all of that being said, let's actually walk through how all of this works, and walk through an example. So on Uber's container platform, we have a controller that will create a pod, and we also would always create a pod extension to go alongside with it. So there's a one-to-one relationship between these two. Then we have our friend the kubelet, which sees the pod, and it will process the container, makes the call to the CRI runtime, and then it makes the call to the node resource interface. We have our plugin that we've registered. The plugin is also able to look up which pod this specific container belongs to, and then also because of that information, we can also figure out which pod extension to look up. Then we can figure out the specific configuration that we need, make any changes, so we can tweak C groups, we can edit the request. So for example, we could also add a specific container label here if we wanted to. We return our response to NRI, and then it goes back to the container runtime and our container is created. And we've changed it and mutated it in a way without the kubelet necessarily knowing about it. You might be asking yourself, what if the container is already running? So in the little flowchart that I showed you, all of that was triggered because the kubelet did something. So we can also deal with that in our own way as well. So we have our pod extension, and we might make a change to the pod extension. And if you remember the NRI plugin, we turned it into a controller. It's just a simple Kubernetes controller. It watches the pod extension resource, gets the changes. Okay, maybe we've added a specific container label now to one of our containers. The NRI plugin sees this request. And we can also do essentially an out-of-band request to the CRI runtime by calling update containers. So then we can mutate the container in place, and kubelet didn't trigger anything here. So then we finish the flow. We've made a change to the container. We've updated the resources, added a container label, anything that we would need for our stateful platform. We have the container running. And also, kubelet is just sitting here and was not involved in this flow. So let's take a quick step back and see what NRI actually gives us. So in essence, NRI gives us a hook between Kubernetes and the container lifecycle. So it gives us it gives us a hook into to make changes there where we normally wouldn't be able to. It also, like I just mentioned, gives us a way to mutate containers in place. Typically pods are more immutable, but at least specifically for Uber's stateful platform, we needed a way to mutate these containers to reduce scheduling, rescheduling databases on different hosts, because that's a very expensive operation that we would like to minimize as much as possible. Yeah, let's just quickly go over the features that Johan mentioned. So with NRI, we're able to, we have all of the resource controls that we would need because we have full control over the C groups. We can edit the resources however we want. We can edit them in place. So we have full control over that. So we have everything we would need for the resource controls. Additionally, there's the container controls. So thankfully, everything inside of this OCI bundle that is configurable and that we can edit, these are all features that we would have needed in the stateful platform. These are all things we can configure via this OCI bundle, like the container labels. So these are things that we can support here. Additionally, some other features that we would need is like score adjust, like if we have multiple containers, which one gets killed first. And there's like a few other features that we needed as well that are all supported by editing this OCI bundle. Now, we built all of this in mind, and at some point we want to deprecate NRI. We built all this amazing tooling, but eventually we want to be more Kubernetes native and be like just purely 100% on Kubernetes, because we realize some of the things are maybe pushing the boundaries a little bit of what we should be doing. So we built all of this with deprecating NRI in mind, so we could get rid of the plugin at some point. So we did that. We had an exit plan. So there's a few things we can do to get rid of the NRI plugin. The first and most obvious one is to just adjust our requirements. So some of the specific features that we might need, that our stateful platform needed, that we couldn't regress on, some of them are more important than others. And the ones that are less important, we could just simply drop that requirement. Like I've been mentioning some of these container labels, like yeah, sure, you can add a label to a pod and then all of the pods have the label, but you can we also needed to add a label to a specific container and not the other containers. This is not a super important feature though. We just needed to make some things easier, but NRI was there, so we used it. And these are some of the features we can just simply drop over time. The other thing that's a little bit more difficult, but there's obviously progress being made, is we can have upstream catch up. So like I mentioned, these pod level resources, this is something that's coming in Kubernetes and is something we will also be actively using and need to use in our stateful platform as well. Finally, at some point, we will want to entirely just get rid of this plugin because it's just, it's an extra component. One less component is always good. So some lessons and takeaways. What should you take from this? You might be thinking to yourself like, oh, I can go home now and go back to work and use NRI to make all these crazy, amazing features. And for us, that was like, it was definitely the right choice. It unblocked us. It made the stateful migration actually possible because there was a lot of these features that we just couldn't build without NRI. So it's like a matter of regressing very important features that we needed and being very costly, or using this NRI plugin. So for us, it was definitely the right choice. But there's definitely some things to consider because if you couldn't guess, you're going against the grain a little bit. Pods are, at least initially, they've been designed to be immutable, and we're making the pods more mutable by changing C groups under the hood, by changing stuff before kubelet is actually able to, or without involving the kubelet. It's also extra complexity. Like I mentioned, it's another component, it's another thing that could potentially fail. And yeah, it could just be easier to change your requirements, like I mentioned, so you can save yourself the hassle of implementing another component, if you can change your requirements, that is. So some reasons why it might work. Like I mentioned, it really unblocked us. If you have some kind of specific feature that you really need and you think that this is something that could make it to upstream Kubernetes one day, but you have some specific business needs, NRI might be the solution for you, and then you can investigate and see if you need this, if you could leverage NRI. But at the end of the day, everything is just, it's an engineering trade-off. You have to ask yourself these questions. If you really want to be using NRI, can you change the requirements, all of this. Alrighty, that's everything from our side. So if you were inspired to check out NRI, I have a link to the Containerd GitHub repository here. Also, we've solved some interesting challenges at Uber as well. So if you want to read about other interesting challenges Uber has solved, you can also check out the blog. And yeah, that's it from our side. Thank you.